Right, greetings everyone. A warm welcome at Exchanging Ideas 8 Global 5G Evolution. Kindly take a second to subscribe this YouTube channel by clicking the subscribe button. I'm 𝗃𝗃cie𝗿𝗁𝗃. A big welcome to this YouTube Global 5G Evolution. It's a pleasure to have this wonderful session with everyone. A warm welcome to great speakers around the globe. Now to start on, I will present on the topic of 5G private networks, Europe industry use cases. Now, the question that I have in mind is that why this is the time for enterprises to deploy private cellular networks. Firstly is the demand. Digital enterprises need to collect and analyze data to drive business customers. Enterprise need for flexibility, mobility, and security. Data and the convergence between IT and OT enable enterprises to gain improved visibility into their operations. The other point is that Wi-Fi does not consider reliable enough. It does not support mobility and its performance degrades with increase of users. The other point is that there's a new needs and also use cases. Enterprises have multiple needs with different requirements. For example, IoT and a workflow connectivity, and there's so many number of applications that involve data analytics. Also, when it comes on automated guided vehicles or augmented reality, virtual reality, those cannot be properly supported by the traditional connectivity. And lastly is the network virtualization and edge computing. That is the one that's coming, what we call the future, where it really needs the 5G strong support. As you see on this slide, the three main areas that is dominating is manufacturing, followed by transport and logistics, and energy, mining, and utilities. Now, this is another area that we see that private networks can help meet industrial enterprise where we have a key business drivers. Number one, to minimize production lines downtime by using a highly reliable, highly scalable network with SLAs from MNOs openly to cover the uptime and the availability. Number two is the enabling manufacturing flexibility by supporting reliable, high bandwidth wireless connectivity. Number three is monitoring and management of goods and supplies across supply chain. Number four is enabling high reliability, critical monitoring and control applications in primary production industries, mainly like mining, oil extraction, and quarrying. And number five is maximizing its productivity and manufacturing output quality. Number six is support real-time decision making using locally deployed edge processing capabilities, along with local ultra low latency network infrastructure. And lastly, one of the key drivers is the security, right? So protecting IT and operational networks against the cost and disruption of security and privacy threats. So these are the key drivers for such a private 5G network. Now, what you have seen in this screen is the four main dominant area where industries covering the manufacturing, the transport and logistics, healthcare, and the energy and utilities. Now, let's specify the number of use cases in manufacturing itself. We have remote expertise, AR, VR, automation with robots and cobots, smart connected tooling, defect monitoring with machine vision, and end-to-end traceability. And this number of use cases just very much concerned on the product build and the quality. On the other hand, when it comes to the factory efficiency, we have use cases like predictive maintenance, asset tracking, power and heat management, machine vision and plant management, replenishment of machines to the workstations using the automated guided vehicles. And these are very much involved with advanced analytics tools. The other area of is the transport and logistics, particularly in smart port. You know, we have use cases like to improve the port traffic management, improve the port operations, remote control gantry cranes, remote control quarry side container cranes, cross vehicle control of AGVs, video surveillance, real-time asset tracking. Healthcare very much towards to connected ambulance, remote patient monitoring, virtual calls, and X-ray and MRI images. When it comes to the energy and utilities, it's very much involved on use cases such as drones and supervision, cloud robotics and process automation, mega campus management, video surveillance, remote control management, and machines. Mining, yes, mining is one of the key use case for 5G private network when it comes to driverless electric haulage, HD image backhaul, and intelligent scheduling, autonomous driving, such case. So moving on to the next slide, this is very interesting when it comes the three main key areas, particularly I'm looking for in the Europe use cases. Now, when you see at the bottom, the hybrid networks, it's very much where the mobile net operators, including the Deutsche Telekom, Telefonica, and Vodafone, are offering hybrid 5G network solutions that offer flexibility by incorporating both public and private networks to suit the full range of industrial enterprises. And this use of public cloud provides, it's a combination, right? We can have a public cloud providers and also public network providers to create this hybrid model, right? Where most data processing, it's completed on the side. Or we can have an isolated edge infrastructure, right? But data can also be stored and accessed from the public network or a cloud service. You know, the example like a logistic use case. This part is the private network. It's a very much of a dedicated private network. And it's a completely isolated system with no external input outputs to the mobile network operators. And all data and processing are completed and stored on the site. And it's a standalone private network and via operator spectrum, or it can be applied by a private spectrum. This part is the public dedicated networks, very much towards utilizing the SLAs offered by the mobile network operators. And it can also use network slicing for specific use cases. And also it can be an option with local infrastructure, for example, using a RAN privately on dedicated industry and sharing the core network offered by the mobile network operator. An example that's a leading private network when it comes to a combination of LTE and 5G, there's more than 140 use cases offered by Nokia. They are far leading in the private networks, particularly in Europe and another part of the world. And if you can see that the main areas that is being offered industries are the manufacturing industries, followed by the hospital and labs, water utility plants, and warehouses. This is a typical use case when it comes to the use case from Nokia to give an idea on the digital factory campus, shop floors, connected workers, and smart assets. There's so many number of use cases that we can able to see here. Interestingly, when it comes to the Nokia Digital Automation Cloud, where you know the most MNO's efforts in automation are limited to specific parts of the network and IT infra, right? So this is because automation is often developed as a standalone scripts used by separate domain teams such as IMS, 5G Core, and NFVI. So automated networks, you know, it gives some sort of a platform where to supply the delivery within weeks towards the end customers, right? So whatever industries they want to have these use cases to be delivered with a specific customers' interest. So this kind of automation cloud able to give some sort of a quick delivery of life cycle, and that it is proven that it gives some sort of delivery time up to 74% and reducing the delivery cost within of 31%. This slide is from Qualcomm, just to give an idea of all the relevant successful 5G private networks. For example, in Toyota, Verizon, Ford, Lufthansa Airport also has been successfully done a private network just purely on 5G. And the other area I would like to stress is the 5G ACIA. 5G ACIA is an alliance for connected industries and automation, and they are very much focused into the manufacturing industry. They have an ecosystem where there's a lot of discussions going on between the manufacturers, the technology providers, network operators, in terms of the spectrum advocacy and the collaborations. And this is just to give an idea from Qualcomm as well, the private edge infra, how the cloud processing distributed AI can be done. And very much it is giving some key benefit in terms of low latency, real-time asset tracking, and also the famous digital twins predictive maintenance. All those processing power can be done at the customer premise quickly. Lastly, I would like to stress that most of the industries in Europe and also the other continents, where the 5G private networks are very much focused in the spectrum of between 24 to 30 gigahertz, where licenses are being issued towards to the small medium enterprises or manufacturers or ports or airports, those kind of direct clients, and those clients can able to utilize those spectrums without the need of sharing with the mobile network operator. So this is all about rough information of the 5G private network from me. And I would like to pass on to the next speaker, Karim Rabi from Riyadh, Saudi Arabia, to present on the 5G private network, the concept.
Thank you, 𝗘𝘃𝗽𝗍, and thanks to all of you. Please update me if you can see the slides.
Yes, perfect.
Okay, great. So in 10 minutes, I'm going to talk about the technical concept and some of the deployment flavors of the private 5G. I hope that this can be like a foundation for the rest of sessions by the colleagues. Let me start. Just a quick introduction about myself. I'm mainly currently focusing on the 5G from the automation and orchestration aspects, but all my background is actually from the mobility. So I'm a core guy basically. So I'm trying to mix that with my current focus in the automation and machine learning and orchestration. I prepared let me say like a basic agenda that tried to cover the foundation, a quick refresher about the concept of public network, and then we go to the non-public network, which is the standard name of the private network in the 3GPP, and I'm going to list some deployment flavor in 10 minutes, and that's the challenge. So just quickly, since the start, like GSM, 2G, 3G, 4G, 5G, we have been always engaged, and we all know the concept of the public network, which is actually the mobile network that is actually implemented and leased or deployed for public use. And we all know the ID, the identifiers, the standard terms like the PLMN ID, which is the public land mobile network ID. This has always referred to a public network offering public services. And I'm giving an example here. For example, that's an Orange Egypt. It has a mobile country code, a mobile network code of 602 and 01. This means that Orange subscribers that have this kind of 𝗬𝗎 range are the only subscribers that are allowed to attach or connect to this public network. So the network is giving a public service to their customers. So that's the public network. So what is new in private or in non-public network? Simply the non-public network, and again, that's the standard term used in 3GPP for all of us not to be confused. It is the same term as private network. It is simply, it's a 5G system or 5G like RAN and core 5G network deployed for non-public use, ideally for enterprises or for organizations. And the same way we were limiting the public network access to the 𝗬𝗎 range or subscribers of the public operator, we will do the same, but for a private use, for a certain organization. So the access and the interaction is only limited for the users of this organization. And that actually complementing the example that you have given, 𝗘𝘃𝗽𝗍, for the factory. So we're talking now about the factory users or the factory employees. The technology itself, it's being standardized in 3GPP-R16, and that was closed in June 2020. So we should expect a wave of deployments, let's say from 6 to 9 months. So by the end of this year and next year, we expect like a wave of deployments. This is how we used to monitor the actual deployments after closing the standards. From a standards perspective, there are two modes of deployment. And let's memorize these terms because I think they will be very trending in the next coming years. So the SNPN, or the standalone non-public network, and from the name, it's standalone, it is isolated, it is not integrated by a way or another to the public network. This has some challenges for sure, you know, of the spectrum, of the infrastructure, the mode itself of the operations. And I see there one session in the list today about managed services. So I'd be interested to understand how we can do managed service for such isolated private network. But there is also the other one, which is most probably, I would say the majority of the operators, at least in my region, will start to adopt, which is the PNI and NPN, which is the public network integrated non-public network. This means that the private network, in a way or another, will have some sort of integration or interlocks with the public network, in a way of network slicing, in a way of sharing RAN, in a way of anything, but there are some sort of integrations. From GSMA perspective, and it's a little bit, I would say, user-friendly explanation, these are like the modes of deployment. And we can just go scan it quickly. You can start with a private network that's actually part of the public network. And we have seen that in a way or another with the enterprise services that the current public network is providing, like the corporate APN, for example. You can just get an APN or DNN in 5G, and then you can have like a public service, a private service in a public network. Or you can have like some similar setup, but with a strict SLA. So you pay by SLA. You don't pay by number of users, but you as an enterprise customer, you buy SLA, certain quality of service from the public network provider. Or you can just go and little bit have some sort of evolution and do having a network slice, or you can have like some local infrastructure hosted in a public network, or you can start the flavors of standalone by having a standalone private network sharing the operator spectrum, or you can have like the most, I would say, the freestyle service, the freestyle mode, which is again having some challenges, at least in my region, to have a completely standalone private network with a private or with your own spectrum. And as you go to the right, the isolation, privacy, security, and quality service becomes really significant. But again, the global connectivity, so you only have kind of connectivity to your standalone network, not to the public, start to decrease. So in the next 2 minutes, I'm going just to scan the deployment flavors quickly. The standalone, the fully isolated, you see the private network is completely isolated from the public network. You get the best quality of service you can have, the highest latency. You have as a private customer or enterprise, the full operation visibility, 100% security and privacy, but you lose any kind of service continuity between you and the public network. So if it's a really isolated environment, then this model makes sense. If not, then you will lose the kind of global connectivity or the mobility between the private network and the public network. The shared radio is common, so you still have your private network, you still have your privacy, your operation visibility, but for CAPEX and OPEX stuff, for regulation stuff, you are sharing the radio with the public network, and this model is quite famous even before the 5G. What is I believe personally that's going to be the start always of the private 5G is having the private 5G or the non-public 5G on the basis of network slicing. So as you see here, the private network or the enterprise customer is having his own slice of the user plane and services and sharing the control plane and radio. So the security and privacy a little bit decreased because now you're going to share the enterprise data with the public network data, maybe in the repository or whatever, but still you can get much benefits from the service continuity and the overall device connectivity. And then the last thing, and that's actually the simple one, and I don't think that this will be considered as a private 5G deployment, is you can still get also your services hosted by the public network by having a DNN like an APN. But that's I would say it's a very loose model of the private 5G. So you start from isolated 5G, private 5G, till you reach this model. But I believe personally that we are going to start with something in the middle, which is ideally the network slicing. Those were the slides from my side. I hope I was able to give a foundation about the private 5G and ease the job of my colleagues on the coming sessions. 𝗘𝘃𝐺𝗿𝘁, back to you. I hope I
Thank
made
you.
it in
That
10
was an
minutes.
excellent presentation, Karim. Thank you so much.
Thank you.
So let's move on to the next speaker. Is 𝗚𝗃𝐺𝗿𝗁 Pascarella from Denver, Colorado, US, to present on the 5G managed services model for private networks. Let me give you the co-host. Are you able to share screen right now?
Great. Yeah, let me try here. All right. Oh, looks like I have to rejoin real quick. Sorry, give me 1 minute.
Or shall I? Oh yeah, there's okay. Jennifer, I would like to invite Jennifer Dudek from Frankfurt, Germany, for presenting 5G low-cost players, SMEs in the market.
Yes, I can start. Sorry for the camera, but every time I want to turn my camera on, it's just leaking really bad. So I'm just gonna present now. Wait a second. Share screen. You see my screen, right?
Yes.
Okay, perfect. Let me just get prepared a little bit. Yeah, so I'm going to talk about 5G low-cost player and SMEs in the market, but it was kind of hard finding low-cost players without having like any specific expensive research papers. But I did some good research about it. About myself, so I just graduated in industrial engineering and management in Frankfurt, and I wrote my thesis about 5G in Asia Pacific. But I moved to London and I work at Moody's Analytics and financial services now, so I kind of changed my industry. But I think for long term, I'm going to go back to the industry for sure. So my agenda is I talk about key players in 5G, small and medium-sized enterprises, then the key opportunities for the SMEs, benefits for SMEs with 5G, and why do we need startups? I think it's also important topics. So key players in 5G, I found a really good overview where you have like for each segment, key players like cloud services, data center colocation connectivity, CDN, content delivery network companies. Then you have 5G infrastructure vendors. You have mobile carriers. Then you have 5G mobile chipset technologies and mobile device makers. And it's interesting because you have cloud services and data center colocation connectivity, which is kind of the start. And then mobile carriers and mobile device makers is the end consumers. So this is the whole value chain. And it's really cool because I think someday we're going to have this kind of overview with SME and startups, which we don't have right now, unfortunately. But just to understand how the value chain is built. So then I took a look. So what are the most important technologies we need right now and where there is a gap and the win position for SME companies? So SMEs are leader in technologies which are needed to solve, for example, spectrum allocation problems. So we have beamforming companies for mobile business models where we have arrays, gap waves, and Movandi. Movandi, by the way, is working with NXP Semiconductor company. They're working on a collaboration, which is really cool. And there's even the talk that one of the biggest semiconductor companies is buying them over. Then we need technologies for supporting new services in areas. So that means we have edge computing and small cells. That means I found interesting companies, 𝗃𝗃𝐺𝗿𝘁, Unnamed Live, and Zomeet. Just to tell you a little bit about the companies, so 𝗃𝗃𝐺𝗿𝘁 is developing AI that can effectively integrate 5G wireless system. Then we have Zomeet, that's a Netherlands company from Amsterdam, which is working on a speech technology startup. That means not preparing speeches, but like recording your voice and making them better in real time if someone just using the lips and not talking, but instead someone else's voice is used. Then we have Unnamed Live. This is interesting because it's they call themselves autonomy as a service company. So that means they want to connect and integrate teams of different types. That means they want to connect drones and robots. And these drones and robots are working together with collaboratively with Industry 4.0 and smart cities. Then another important point, edge computing and small cells for the future. No, this was machine learning and big data. And then we have edge computing and small cells. And there I found two interesting companies. We have Olive Edge enabling 5G applications through open APIs at the edge for AI, AR, VR, and smart cities. Via edge gateway, that means everything is connected with one edge and not several edge computing and small cells. And then we have Federated Wireless. This is the first US company for small cells, which are using 3.5 gigahertz public spectrums. And then I found 3 startups. These are mainly in Europe and based in Europe. So I found Inuroot. Their expertise lies in network protocols and HV design. And they work more in the vertical sectors of Industry 4.0, automotive, media, entertainment, and e-health. And interesting is they have like a product that's called TrustNode, and they provide ultra low latency forwarding for time critical IoT applications. And the expertise, as I said, it's important to have like IoT, like time critical IoT application in Industry 4.0 and in the automotive manufacturing sector. Founded in the year 2010 with only 10 employees, but their expertise are really good. Then I found a company from Poland, IT, e-technologies and business. Their expertise lies, like their 5G related domain expertise lies on admission control, congestion control optimization, quality of service. And their expertise of industry is e-health, energy, and public safety. That means in e-health, they have like a solution, it's called 𝗦𝘂𝗽𝗍 solution, and they offer telecare support for remote patients. That means someone is in the suburb area and the doctor can't come there. So this is what they offer, 𝗦𝘂𝗽𝗍.com, the homepage. Then we have energy. They want to, it's like an optimal control for smart cities. That means they want to control the energy efficiency of light control and energy management in the cities. And then public safety means they have cameras. They kind of want to have cameras to control what is happening on the streets. So where may be dangerous areas where they can prevent that. Foundation, yes, 1996, and 80 employees are working there. And then we have another company, it's called Wing Solutions. They expertise in 5G related domains are smart wireless access, cloud continuum software networks, and big data analytics. And then the expertise in vertical sectors is health, energy, finance, automotive, IoT, and much more. Also belongs to the startup scene, to be honest. Not quite known in the big industry, but they're good at what they're doing. And my next slide are the benefits for these companies, for SMEs. So the good thing is that they always fill a niche. That means if there's a need for something smaller, it's like impossible for big companies to find that niche because they don't have that money to have this research and development team. Then they're traditionally agile, and they're in the edge of technology innovation. That means they don't offer the exact product, for example, like Cisco or any other big player. And this is the pro, that they have like a small team and they can work on a specific solution. This is really good. And the goal is they can reduce costs and increase revenue because they belong to the game changer that help them to increase productivity and efficiency, and they create new opportunities across the value chain, which I want to talk about. The first slide I showed you with the value chain with all the big companies. You have all these big companies, but I would say that the SME and the startups are everywhere in between these big companies. And so why do we need startups? I think startups are like shaping the world where we live right now. and startup-led most 4G services application development innovation. Therefore, SMEs have vital for the growth and development of 5G opportunities because, as I said, there's going to be a lot of need for specific niches. And I think small companies and startups, they can fill these niches, especially with investment, which we have in a lot of countries, especially like in Germany where I'm from, or in EMEA. Yeah, that's all. Thank you.
Perfect. Thank you. Thank you so much, Jennifer. So let's move on to the next speaker, 𝗦𝘃𝗽𝗃 from Denver, Colorado, US, to present on the 5G managed service model for private networks.
Great, thank you. I should be ready to share my screen now. Would you mind giving me the presentation capabilities? All right, great. All righty, let me know when you all are able to see.
Yes, perfect.
Awesome. All right, so we'll be talking about 5G managed services for industry today. Appreciate the opportunity to speak with you all this morning. The presentations have been great so far. So I just prepared a few slides to walk through and maybe even leave some time for discussion. So as I'm sure we all know, the relative network landscape for customers, who might be adopting these networks, particularly in more heavy industry or asset intensive industries, are quite fragmented and uncoordinated. There's many networks out there today, many networks used for different things, and cellular and private networks are becoming more prevalent, especially in the use or in these industries to help cover both some of these use cases, both on the device side as well as on the enterprise side. 5G promises to solve a lot of the flexibility and performance issues of a lot of these other networks and can serve as an overlay to many of the existing networks in these environments today. So, one of the things that we talk to customers about all the time is that people aren't going to just rip and replace all the networks that are in play today, and instead may adopt 5G or similar networks as a way to coordinate or aggregate data across these different other network types to help drive any particular use case that they're looking to enable. With that said, and as we were talking about earlier, I really like the presentation on the different deployment models. This is definitely a more simplified version of that. But these types of private networks can be deployed in multiple formats, whether we're talking about LTE or 5G. And so whether it's more of a virtualized private network or it's over dedicated licensed spectrum, shared spectrum, or unlicensed spectrum, there's many technologies coming together to help enable this. There's many players coming together to help enable this for customers. And the actual deployment format somewhat depends on the use case, somewhat depends on the players involved, and somewhat depends on what the customers actually understands about the value associated with these types of networks. And so one of the questions that we speak a lot with clients about is, who owns the network, who provides the service, how does this actually get set up for customers? As I said, highly depends on which players are involved. And so again, while this is a relatively general overview, I think the point here is that it raises questions about the actual deployment models and the business models involved. And so when we start to think about managed services, these are services that can be provided by maybe a more traditional supplier out there in the marketplace today, or a third party who might have been supplying services previously to customers, maybe more so in the OT or even in the IT realm, and who is moving into these new private network services, as well as maybe a new supplier who isn't familiar or hasn't offered these types of services in the past, or is a brand new service provider on the market today. And so if we think about the types of components and what they enable for customers, you know, while any managed service could be different, we see it generally as having three main capabilities with many sub capabilities: custom network design, engineering, and installation. So the ability to set up a network within a customer's environment to meet their needs and requirements. Network management platforming capabilities, including some of the bullets below that: network access management, cloud computing, or 𝗦𝘂𝗽𝗍, quality service management, security and firewall management. And there's many other capabilities that fit within there, but those are some of the primary ones that I wanted to highlight. And then on the customer technical support and troubleshooting, or help desk. So really all three of those main categories provide the ability to provide that end-to-end managed service for customers. This can generate a lot of different benefits for customers. So, you know, from you know, generally speaking, what we see is that there's many of the customers, especially in heavy industry, so places like manufacturing or even ports or warehouses, or maybe natural resource extraction environments like mining, oil and gas, typically have some network capabilities internally to offer or to assist with the networks that they have set up today, but they might not be completely aligned with these types of capabilities, and therefore would choose to work with a network service provider. And so we see that ability to extend these internal customer capabilities with more experienced network and service provider to be you know, one of those top benefits. And then obviously the translation of all of these components into how the customer receives them. So custom network configurations, you know, potential for lower upfront costs on network hardware and infrastructure. This helps provide, or if it's provided as a managed service, you could shift some of that cost to OpEx as opposed to upfront CapEx to deploy these systems. Definitely enhance security of the network and the connected systems on those networks. There is a huge potential for a greater integration of OT and IT from all the way from the enterprise, plant, to edge and device. This is important, especially as you know, maybe more traditional suppliers or an OT systems integrator, for example, pivots or expands to offer these types of 5G managed services. And also, this is you know, one of the key value props of these networks is the upgradable and scalable across dispersed sites and operations. So specifically driven by managed services, there's a lot of benefits there. At the same time, there are some drawbacks. So less control over and visibility into the actual network that's being used. Typically, when there's a service provider involved, they'll keep kind of pretty close control over that portion. You know, how the service is being provided. You know, there's the if it's not done by the customer itself, you know, there's the opportunity for the network to be over or under spec'd and maybe have an overall higher cost, even if that cost is driven by just the service that's being provided. And then there's, you know, if the service provider is somebody who's coming in from and hasn't traditionally participated or offered services to this customer, that there may be lack of effective integration there. However, I think all of these are more of you know, anecdotal drawbacks than you know, drawbacks that occur all the time with these types of managed services. And so, you know, where is all this heading? So I think you know, hybrid network management will happen across these environments. So the ability to combine all of these different network types into a single you know, network platform that leverages a lot of these key enablers from 5G that you know, can help drive greater visibility, more autonomous network switching, and optimized bandwidth usage for whatever use case that the customer is looking to enable, and have that be the case for many use cases across these customer environments. And all of this, I think, is much better done by a managed service provider. The ability to see across suppliers, across systems, and help customers with a variety of use cases, those that have been networked in the past and those that are coming online here today and in the near future. So I put these in here, just it's always good to think about kind of where these questions are going. It's interesting to understand that there's not much. I mean, there's a lot of talk out there today about managed services around 5G and private networks. I think it's a huge opportunity, but there's, I think, a lot of research and a lot of activity still to come in this space. And these are some questions that I would take forward for further research and consideration. Great, and that is it for me today. Thank you.
Brilliant, Harry. Thank you so much. Moving on to the next speaker.
Sorry, I was late.
I would like to introduce Yogaratnam Rahulan from London, UK, to present the advantage and disadvantage of 5G private networks and shared spectrum.
Yes, my name is Yogaratnam Rahulan. You can call me Rahul. I'm a chief architect at 5G Innovation Center. But I'm going to talk about the, rather than disadvantage, I'm going to talk about the private network advantages and challenges. And what are the spectrums available for shared spectrum in UK as well. So I'll just going to start sharing the slide. So can you see my slides?
Yes.
So the main advantage is the security and privacy for the private network. Wherever you have your own data within the premises, so it doesn't need to go outside of the premises. That means the security-wise, the data security is safer, and also the privacy means any user profile data won't be able to travel outside of the premises. And also when you talk about the private network, all the network on one platform is a unified network that has been defined in 3GPP, which can authenticate and authorize within one unified 5G core. It never happened in previous traditional cores, and this is the first time in 5G they brought everything in one platform to authenticate and authorize. And it's more effective and efficient technology that also facilitate the subscriber supervision tool for quick action by introducing a new functionality within the 5G system. So it's more the system is service-based architecture that introduced in 5G, bring them the tool to integrate with each of these functionality to supervisions and in the real-time monitoring and making the quick action. So that's why I'm saying it's supervision and tools and make the quick action. And also it's easily manageable rather than previous generation for scale in, scale out process. If you have a proper system integrated within your private network, scale in, scale out is much easier. And to talk to multiple interface, multiple network nodes is manageable, and it's been defined in as a service-based architecture. You don't need to worry about proprietary network. And by keeping in the private network, so it's you can see the uniform and uninterrupted by any coexisting connectivity. So you can coexist with Wi-Fi system, WLAN system, and radio access. All the access network can coexist part of this 5G network across the world. The challenges, yes, still under research because they haven't fully done most of the work. It's been defined in 3GPP, still the practical work still undergoing. They haven't done a full implementation and all the technologies. And also the speed of the technology and the use cases and climbing very fast. It is difficult to achieve some of the technology within the private network. Whereas if it's a operator's network, a private network, they will adapt very quicker than private network. And the other thing is many of the old devices would not be able to compensate with 5G. So we need to replace, if you have a legacy system in a factory, so anywhere which talking to 4G system or the old Wi-Fi system, it's really hard to integrate with the 5G system. And the developing infrastructure cost and operational cost, it's higher for the private. These are the challenges on the private network compared to public network. The next thing is I'm going to go talk about what are the options they can deploy the private network. So this is one scenario, option one. So you can deploy a private network within the factory and can talk to the public network. Currently the 4G network is available most of the places, so that this is how you can actually deploy. So you need to have a interworking function between the 5G private network and the 4G network, so they can talk to each other via the internet. So this is the one option that for the current space that most of the places in UK, not everywhere they are 5G deployed at the moment. So this is one of the option. The next option is, like I said, enterprise private network. So this network, it can be any home. So this is the enterprise private network. So any biggest manufacturers like a Bosch, Masak, so all those people, they can have their own private network, publicly operated, and also can communicate to the public network through the secure authentication system. So they can have their own slices, own private network, and those slices can be talked to the public network through their secure authentication system. This is also in place in most of the places in UK. So Bosch and Masak is one of the examples that we were worked on. So they can all the LAN system. So as you can see, these wired connectivity system, and also the radio access network, Wi-Fi access network can talk, get authentication from the 5G core system. So then you can actually have everything unified security enable 5G core that can authenticate all these devices. And it can also securely communicate to the public network, so that it doesn't need to, the data doesn't need to travel to the public network. If you need to fetch something from the outside of the world, yes, it can go to the internet, talk to the public network to get those data whenever it's needed. This is another point. This is spectrum sharing for community, especially for the rural community. We are currently working in Scotland, called Orkney. This is very rural community. So they need to have the community will deploy the radio system, and they need to have a neutral host in order to talk any operators in the right-hand side, so as a public operator network. So the neutral host is going to play a biggest game on this the community led private network. So this is a shared spectrum coming in place. So on the right-hand side, if you think about the operators, these can be, a single operator can have multiple virtual MNOs. So that can operate, operator A can have multiple virtual MNOs. And on the community private network, if they buy from virtual MNOs, they can also talk to these the shared RAN spectrum through the neutral host. This is one of the options. And finally, the different funding model for the private network. When we talk about this different funding model, I also going to talk about the this is, I got it from the American 5G technology private network white paper. So the funded by enterprise, it can be funded by wireless operators, our hybrid funding model that I talked about, the community funding plus operator funding. So there's a hybrid model funded by neutral host company. So for example, if Cisco or any other vendors or service providers. If they become a neutral host company, they can fund part of these private network for the community side for shared spectrum. In UK, what we have, so the most of the shared spectrum is in UK is under 3800 to 4200. So this is the currently 5G spectrum they allocated in UK, and also they are considering the band 1800 to 2300 as a spared spectrum, which is a 4G spectrum. It's hardly used this spectrum in previous network. So they are considering, Ofcom, UK Ofcom are considering to use the 1800 megahertz to 2300 as part of the shared spectrum as well. So this is being released in the Ofcom pay website. So the new license system introduced in July 2019 to access the 3.8 to 4.2 gigahertz band and 1800 to 2300 shared spectrum. So this is the 5G spectrum is only 3.8 to 4.2. It's been allocated to use for rural community for shared spectrum. Also can be used for any enterprise network or private network wherever they want. Just only £950 the license fee, so they just can buy it and use it. Again, they also mention when they're using this shared spectrum in the future, if multiple industry if they plan to use this spared spectrum, they need to talk to each other in order to reduce the interference between those manufacturing industries. So these also been defined in the Ofcom website for those who wanted to have this private network for their premises. That's my final solution. That's the end of my presentation for today. If you have any question, please ask. I can answer them. Unfortunately, I couldn't go too further because of the 10-minute schedule. So I just need to finish within 10 minutes.
Awesome, Rahul. Appreciate it. So moving on to the next speaker, Sriram Rupanagunta from Karnataka, India, to present on the virtualized 5G private network.
Hey, thanks, Ganesh. Can you all hear me okay?
Yes.
Okay, let me share my screen. All right, hope you all can see the screen.
Yes.
Great, thanks for the opportunity to present here. So my name is Sriram Rupanagunta. So I am one of the founders of a company called Aarna Networks. So we are based in San Jose and in Bangalore, India. So we work in the private 5G edge orchestration products. So that's our focus. So today I'm going to cover the virtualized private 5G networks. So what are some of the characteristics and what are the requirements of these virtualized networks? Hopefully it's complementary to the rest of the presentations. So for some terminology, most of you may be already familiar with it, but just to kind of do the level set, because these are important for virtual networks, right? So the virtual 5G networks can be run, they essentially consist of three possible functions, right? One is a virtual network functions, VNFs, and these are the functions that run as virtual machines, right? The second is the container network functions, which run as a containerized applications. And the third is the physical functions, which are the PNFs. So essentially, whatever was earlier running in the earlier generations as physical functions, so a lot of that is being migrated to running as either VNFs or CNFs, right? So that's one of the transitions that's happening in the 5G. Though it started in 4G, it's more prevalent in 5G. So there are still physical functions. Obviously, things like radio are all going to be still physical, but a lot of the other higher level functions are going to be running as virtual functions, either as virtual machines or as containers, right? So I just wanted to give the terminology so that the subsequent discussions can, will assume these terms. The other requirement is that all of them need to be managed and orchestrated. Right? So that's obviously a requirement for these virtual networks. And so the category of products which do that are generally called as MANO, the management and orchestration. And that's where I'm going to focus on this virtual networks in particular to the 5G. So now, given that sort of the terminology, what are the requirements of the private 5G networks, right? So these are the three main requirements, right? So this is that we believe. So one is a zero touch, right? The 5G network services and edge computing applications, ideally should be with very minimal manual intervention, without any operators, provisioning the networks, configuring them or modifying them, right? It should all be zero touch. There should be a large catalog of these applications, because since everything is virtualized now, there's an opportunity for startups or large organizations to provide applications on top of these 5G networks. Right? So any vertical, be it industry or healthcare or whatever industry that's using these private 5G networks, would ideally want a large catalog of these applications, which will run as either CNFs or it could even be VNFs. The third requirement is something that I think some of the earlier presenters talked about, the private-public connectivity. Right? So that's, it may or may not be there. In some cases, it could be an isolated private network, but that's another requirement that a lot of them might have in terms of the spectrum reuse, slice peering, and so on. So these are the requirements that we see for a private 5G network. Now, what are the capabilities that are required for a lot of these verticals, right? So, so we generally put them in these four buckets. So the first is a reliable connectivity. So I'm not going to go into the detail of that. So obviously that's pretty much a requirement for a lot of these private 5G networks. The edge IoT frameworks, so they also require a lot of the frameworks so that the IoT devices can communicate, can send the data, and then so on. The edge AI and ML, the analytics part of it, in order for us to analyze all these data that's coming in and then provide certain policies and make some changes to the applications. And lastly, obviously, the edge applications, because the fact that it's all virtualized means that there is an opportunity for a lot of these edge applications to be available. So now I'm going to take one specific vertical, and this could be any other vertical. So I'm going to take the industry 4.0 as an example for the 5G virtual network functions, and talk about what are the management problems. Right? So given that this is all going to be virtualized now, it's going to run as a private network inside a factory or or a warehouse or wherever. Right? So what are some of the management problems? Right? So obviously there are other challenges on the radio and all of that, but what I'm going to cover is just application management problem, which is kind of complementary to the other issues. So now the first thing is as a factory operations manager, for example. So what are my requirements? Right? So I need a reliable 5G management in all my factories. So it should be zero touch. There should be network slicing so that I can I can give different characteristics to different types of applications. Ongoing optimizations, because it's not something that somebody is going to sit at a terminal and do it. Right? It should all be ongoing in an automated way, and a lot of the corrective actions should be automatic. Right? So there should be service assurance, where if there are some errors, they should all be corrected in an automatic way. Right. The second thing is I need to manage my edge computing applications. Right. So what that means is that so when you initially start these applications, they're all virtual applications, right? So you need to orchestrate them. You need to be able to start them up in different clouds and make sure that they get started in the right cloud where the appropriate hardware support is available, and they're working in a cloud that gives the required performance, right? And the second thing is the ongoing lifecycle management, right? So these applications may need to be constantly monitored and configured, right? So you may have to scale up some of these applications, scale down. You may have to upgrade the software because suddenly, when you go from a physical to the virtual world, all this become critical, right? And lastly, it should be terminated upon completion. Now, the third category is the process to be fully automated with a one click, right? Because the fact that now it's all virtual networks where there could be lots of these applications from several vendors, right? Potentially hundreds of vendors. So it's not practically possible for anybody to train all their personnel on different types of tools that are available for each of these applications. Right? So it has to be done in a fully automated way, so that there's no need for individual personnel to be familiar with all of these different types of applications and tools. So these are some of the application management problems which are specific to this virtual world. So now I'm going to talk about a couple of these applications which are actually real life POCs that we are part of. And this also talks about how these 5G networks run in the virtual networks. So in this particular case, it's a completely virtualized 5G private network. It's a proof of concept that we have done. So it's a completely public information. So it's all available on the internet. So on the top, what you see is the orchestration, right? So that's where our product is. And I'm not going to talk about that because the focus is more on the 5G virtual functions. So at the bottom, what you see is a OpenShift cloud, which is a Kubernetes-based cloud, and all the 5G functions that you see here are running as containerized applications. So you can see all the functions, UDM, NRF, NEF. So these are all the 5G functions which are all disaggregated. Right? So they all run as individual services as containers, right? And they're all built in a virtual network. And then they all run on the Kubernetes cloud, on the Red Hat Kubernetes cloud. Right? So, and the UPF, which is the user plane function, runs in a performance using some sort of hardware acceleration. Right? And all the other functions run as software functions. So they don't they don't require any specialized hardware. They just run on the standard Intel servers, right? So that's the advantage of running all of them as virtual functions. Right? So that's the 5G core, right? And on the left-hand side, what you see is the simulator. So in this case, we actually did not run the real RAN. That's one of the things that we're going to be doing going forward. But at the moment, we are using the emulators for simulating the RAN functionality, and then also the UE functionality is also emulated. Right? So that's what we are doing right now. But eventually, the goal is to replace all of that with a combination of the virtualized RAN and the physical RAN. So the RU will be the physical, and all the other functions will be all virtualized functions. and then we can show the end-to-end functionality with the end user equipment. And then we also have the firewall, which is also again a virtual function. This is actually run in 2 different sites, which are connected over SD-WAN. And this is connected to the data network. So the goal is to show data traffic going through the 5G RAN and the core through the firewall to the data network, where you can see the data. Right? So this is a completely virtualized network with very little specialized hardware. So most of the functions are running in on a standard Intel servers, except for the UPF, which is running using some certain hardware functionality. Right. So, and what you see at the top that I just mentioned earlier is the orchestration. So that's the one that actually orchestrates all these functions, starts them up in the right Kubernetes clusters, configures them with the day 0 configuration, and also continuously manages them. When if there is any particular function that requires more resources, it will scale them up. So all of that is done in an automated way. Right? So these are all containerized functions. So that's one of the examples of this virtualized 5G private network, which is a real life POC that we have done. So this is another POC, which is very similar, except that now we are actually showing an edge function and a core function, and all the components are pretty much the same. So they all run on the Kubernetes clouds in both the cases. So there are 2 different Kubernetes clouds, and all of the 5G functions run as containerized applications on these edge and the core. And at the top, what you have is an orchestration, which again configures, sets them up, spins up all the required functions on each of these clouds, and continues to manage them. So I think that's another example of this private 5G network in a sort of how the virtualization is done in this case, and how they are managed. So now, what are some of the requirements of these 5G functions, right? So we see three primary requirements, right? So the first one I talked about, orchestrating these thousands of these applications, and given the nature of these virtual functions, so there may be thousands of these applications, and you need to orchestrate them in your private network, right? And what that means is that certain functions may need certain characteristics, right? Some of them may need to be run on the edge network, some of them may need to be run on the core network, and they all have to be started up in the appropriate clouds, right? And there should be a traffic steering, security policies, and the day 0 configurations, right? When they all are started, you need to start them up with certain configurations, right? And the second thing is a lifecycle management, which is and again, these are common to both public and private networks. So these requirements remain the same. The ongoing lifecycle management is something that needs to be done for all these network functions. If there is network slicing, the slicing parameters may need to be modified. Right? So if in a single private network, there could be multiple slices, and they all need to be configured, and their parameters need to be adjusted on an ongoing basis. Right? The day 1, 2 configurations, again, some of them may require a different set of configurations. Change management, cross-cluster scaling, service authorization, termination, so all of them require this lifecycle management. And the third thing is the monitoring and the closed loop. So which essentially is where the telemetry comes in. All these applications could be generating lots of data, and based on that data, there could be some analytics, AI/ML applications that take certain actions on this data and provide inputs. For example, it could change the slicing parameters based on the data that it's receiving. So that's the last that's the third part of the these virtual network function requirements, right? So so I think that's essentially what I wanted to cover in terms of the virtual 5G net virtual functions and what are the requirements in terms of the management and the orchestration. Right. So I think that's all that I wanted to present. So over to you, Ganesh.
Awesome explanation, Sriram. Thank you so much for your presentation. So now let's move on to the next speaker. Let me introduce 𝗃𝗃𝗃𝗁𝗃 from London, UK, to present on the global vertical opportunities and how system integrators will play a major part in moving forward. Yes, Peter, please.
Thank you very much. And thank you to all of my colleagues here and excellent speakers already. Hopefully I've just got a small amount of the topic left to actually cover. I'm going to move on from my background. You can find me on LinkedIn. But I want to look at three areas today. Verticals in terms of where the global opportunity sits, what are the drivers in terms of that global opportunity, how 5G slots into that, specifically drill down into the key use cases and how we get to those use cases, some of the history there, but also where we are today, and then look at the engagement model for 5G. And I've got some specific research that I've done, some development work that I've done, so I'm happy to share this with you. And then as a summary, I'm going to ask them a few key questions, and really these are questions that you should be asking in terms of your own 5G networks, your own engagement with 5G, with your customers, with vendors, with mobile operators, etc. So if we go back to 2018, I had the wonderful opportunity of spending 4 months at the Digital Catapult in London to help them put together a 5G commercial strategy, a value proposition, and also a go-to-market plan. And that focused on the manufacturing sector, the creative sector, with 3 sideways looks at health, transport, and also public safety. And within all of that, I was very lucky to actually engage with not only ABI Research, but also AD Little and Ericsson and Huawei at the time, who were doing similar activities. And really what we came out with was at least 240, if not more, very, very, very specific use cases. But if you drill those down and drill them down and drill them down and drill them down, there's about 24 that actually make sense and that are unique. And then if you drilled it down even further, you can get to about 8 or 10. And I've highlighted some of those on the left-hand side there in bold across the whole of the 24. But as always the case, whenever you start doing this, you start to see other ways of looking at the overall opportunity. So the bottom right-hand corner shows a different view, but now with a weighted score and a relevance score against it, such that it shows that manufacturing and ICT head out top. And yet, is that the overall market opportunity? Possibly not. And we'll come back to that in a second. But I think one of the things that is interesting in doing all of this is we get to this wonderful picture that somebody produced in the bottom left-hand corner here, which is the wide areas of industries that are addressable by private networks. So here we're looking at shipping, we're looking at ports, transportation, we're looking at health, we're looking at oil and gas, utilities, manufacturing, power generation, etc., etc. So when you get down there and you look at how things are done today, you do ask yourself the question, could we do this without 5G? Could we do this with 5G? And always within that, there's a blend. There is a blend, and some of those things and a lot of those things could actually be done better, will be done better in the future when other new 5G capability comes along. But of course, at the same time, we should always think about the most economic and the most efficient way of doing this. So there will be other technologies, and it's good to see that 5G allows those technologies to exist, can actually encapsulate and bring those 5G technologies in. So in all of this work here, what we're looking at is a lot of different use cases spread globally, spread wide, spread in different areas with different requirements. And this is a challenge for the guys putting together the 5G standards, as we've already heard. It will take time to do this. So I wouldn't expect to be able to do all of these things today. In 2023, in other words, 2 years on from where we are now, going into 3 years on from where we are now, the capability of 5G and 5G release 17 and so on will be much greater than it is now, and we'll also have learned a lot more. So where do I get to? I got to here, and this is where Ericsson and 𝗦𝘂𝗽𝗍 ended up to as well. So if we look at the bottom left-hand corner, this is a map of 2016 through 2026 of the global 5G-enabled digitization revenues for ICT players. And there's put a weighted relevance here, and the weighted relevance is against revenue opportunity. And it's a 1.3 trillion total opportunity, with energy, manufacturing, public safety, healthcare figuring highly in all of those. The top left-hand corner is the same picture, yeah, slightly different numbers, slightly different circle, slightly different headlines in it, and that is the 2020 to 2030 compounded view, updated at the end of 2019 coming into 2020, which again shows a smaller opportunity, but now focused on B2B for service providers. So again, what we need to be very careful of is when we look at the large numbers here, is what are we actually looking at underneath? So the top left-hand picture is an interesting one, and that's the one we're going to come back to in a minute. So in terms of service providers, this could be communication service providers, it could be systems integrators, or it could be just very knowledgeable customers. So if you take one of the large automotive manufacturers, they actually have a huge amount of the expertise and capability needed to do some of these things because they're already in that business anyhow. They have to use these technologies. The one on the right-hand side is an interesting one. And this is a bit of hypothetical, theoretical, but also calculated growth opportunity, again, in that 2016 to 2026 window. On the left-hand side there, you see the green numbers. So this is forecasting a 1.5% growth opportunity for ICT. Current operator service revenues, pretty low, pretty stagnant. You're not going to make much money out of that. You're certainly not going to generate the cash flows needed to actually continue the investment in 5G while you've got 4G networks, 3G networks, and 2G networks out there, and existing customer bases to satisfy. However, if we put 5G into this, there is a potential. There is a potential that that 1.5% figure becomes a 13.3% figure. Then all of a sudden, you now have an interesting market opportunity. Whether those numbers will stack up or not, we'll have to wait until 2026 to see. But I think there's an element of truth here that by putting 5G into the mix here, we're actually going to get to a much bigger global opportunity. We will concentrate a lot of the focus around 5G, but at the same time, we'll spread 5G much farther and much wider across the whole of the service revenues, the CSPs, the systems integrators, etc. So we said we come back to the second in terms of looking at the value proposition. And one of the things I uncovered in 2018, and it is still true today, is who does what within that value proposition and how do they engage? So if we look at the left-hand side here, we have vendors who understand the business cases. Why? Because they've spent lots of money with 𝗦𝘂𝗽𝗍, yeah, with API research. They have a challenge of needing real-life ideas, products, applications, and customers. In other words, the vendors can dream these things up, but they do have to get in there and get their hands dirty to do this. So they can offer certain things. And one of the easiest things potentially is for the vendors to engage with SMEs, yeah, because SMEs do actually have that customer coalface view and understand some of those applications and where. And then they can go back to the enterprise customers and circle this information through. But we'll leave that as it is at the moment. Mobile operators understand the technology. Why? Because the vendors have told them all about it. Yeah? So excuse me if I'm being sort of short and direct and blunt here, but I think that's a generalism. Yeah. But it is a challenge. Yeah. Because the mobile operators don't understand the business case, and also can't do the business case in a lot of areas. So I've spoken with CTOs and CXOs of quite a few mobile operators. Yes, they know they can sell millions of handsets and tariffs and work with customers, but they do not have that whole organization that will allow them to sell a service, deliver a service, support a service, and ultimately bill for that service. So for the mobile operators, there's something needs to be slotted into the middle, where you need to really broker a connection between the enterprise customers, the SMEs, create this business case, but then bring them in. So we're really about as it is at the moment. Then we have the enterprise customers. They know their business case. They don't understand 5G in a lot of areas. They do understand the use cases, but from their own perspective, they don't understand them from the 5G perspective. They understand some of the technology and what it can do, but really they don't understand 5G and the technology and what it can do. So there's an education exercise here that needs to go on. You need to have programs in place to actually upskill the enterprise customer and their IT people and their service provider people in all of what 5G can do, such that they then can see how 5G fits in. They then can communicate their own challenges to the mobile operators and to the vendors and potentially to SMEs and so on. From an SME point of perspective, SMEs are brilliant. They have all the ideas and the innovation, but they're out on a limb. They really need some form of platform, and the customers, they certainly don't understand the business case. They're living hand to mouth. They're looking at the next funding round. So they're within the whole of the ecosystem in this engagement. We need to actually help those SMEs. We need to foster them. We need to bring them in front of the enterprise customer, but with the support of the mobile operators, the vendors, etc., and do all of that. Then we get to the right-hand side, and this is an interesting one. We have globally a lot of systems integrators, and they have one big thing. They do understand enterprise. They live and breathe enterprise day by day. So they understand the customer, they understand the business models, they understand how technology today feeds into that. What they don't have is the engagement with the mobile operator. They're not potentially tightly integrated with those mobile operators such that they become a channel partner and a trusted partner to allow the mobile operator to say, great, guys, we're going to go work with you. We're going to work with you as a systems integrator. We understand the opportunity you can bring to the table. Tell us how we can support you in doing all of that, and we will ensure that we can deliver a 5G network, a 5G capability, and a 5G service. So in terms of where the systems integrators are, they need to be able to map the services to the business models. They can certainly design, deliver, and support this, but they need to do this now underneath this heading of 5G. And the systems integrators need to get to understand the CSP type vendors, in other words, the Ericssons and the Nokias, away from the IBMs, the Dells, the HPs, etc. And they need to understand how they can actually work with those SMEs. So I'm just going through a slightly different take here, but it's an important one. So if you look at AT&T, in the summer of 2019, AT&T emailed most of its employees, who are certainly customer facing and had engagement with customers, and asked, have you at some point or other been involved with industry, i.e. manufacturing or similar? If yes, let us know. So over the period of the summer, they got all of the responses back. They then sifted through those responses and then pulled together a team that could engage with industry, engage with manufacturing, and then AT&T could plug into the back of that is the existing 4G offer. And then now it's plugging in its 5G offer, both from a public network perspective, but also, as we've heard earlier, from a public-private network perspective, and that work is ongoing. So that is one operator that's done that. Vodafone in the UK is actually taking a slightly different path, but is actually learning how to do this. There will be operators that won't want to do this, because they see the consumer opportunity as being the big one for them. So that's it at the moment. And if you pull it forwards, the guys will tell you this is, again, it's a much bigger opportunity, but I think we can actually slot into these 8 key areas, and 5G will actually help expand the ecosystem, help expand the number of systems integrators are involved. the SMEs that are involved, the new innovations that are involved. So finally, a set of questions here. I'm not going to go through them today, but there are the type of things you should be asking. Yeah, where does the value reside? Which use cases do you find most compelling? With who, how and with whom do you build those partnerships to deliver 5G use cases and monetize those services? And then what are the challenges in capturing value from 5G and how do you address them? What 5G business models look like and what does it take to adopt them? Then finally decide which industry sectors and use cases to focus on. So that would be for me at the moment. Thank you very much.
I think Kones, you're on the mute.
Thank you, Peter.
Thank you.
Thank you so much. That was an awesome explanation. Let's have a 10 minutes Q&A session. If anyone on board have questions on the topics discussed today, you may post your questions now. Maybe I could start with the first question to anyone who could able to explain. I have this question in my mind when it comes to the 5G network slicing. The 5G, there's quite a number of trials are going on the 5G network slicing, but I'm not really sure whether that has already been successful commercialized in any part of countries in this world, in US or Europe, whether it's really properly commercialized and what kind of pricing rates for such of specific use case network slicing. Is anyone can able to have some information?
I can add one thing that we recently done some TMF digital transformation program for Industry 4.0. We are able to demonstrate the slicing, network slicing using zero touch and digital twin. So you can see from the video I can post later on. So these videos has been explain how the slicing currently working, but unfortunately, the radio side, there's no slicing available commercially at the moment because the standardization just completed for release 16 and they need to finish the release 17 in order to do the proper the 5G radio slicing. It's not ready yet, but the implementation is need to do. But apart from that, the physical, the infrastructure is already there. A lot of people has been deployed, and even the OMC side has been deployed as a virtualization infrastructure. Previously, they need to have a proprietary hardware in order to deploy the radio management system. That now with everything virtualized, most of the stuff has been virtualized commercially. I can tell you, the Vodafone actually have a virtualized most of the platform in UK, apart from the radio. Even though they are working with the Aarna system, Aarna is currently only deploy the 4G system. They haven't commercially deployed the 5G yet in UK. So the first, that's why I said the first initial, the proper slice may happen in a private network, because that's where they can actually easily managed. Whereas when you do the commercialization slice, you need to think about a lot of infrastructure deployment. So at the moment, the infrastructure is a huge, it will take huge time and money in order to give deploy in UK. Once the infrastructure is in place, then yes, these slices can be done. That's the one of the key point that I can stress on here for the slicing. Yes, at the University of Surrey, we have sliced end-to-end, apart from the radio side, full end-to-end with the zero touch. Even we demonstrated part of the digital transformation workshop on these on the TF Forum applications. So you can clearly see that video on the DTM digital transformation marketing place website.
Thanks, Rahul. Anyone?
Let me just add a couple of words there. I've always been a great fan of network slicing since day one, and I think it certainly has some very specific applications. My views have changed over the last couple of years, and I think now that network slicing potentially as a capability on a large mobile or national network is extremely useful. In other words, you can then segment traffic, you can segment services on a national basis. But I'm tending to think now that when it comes to doing private networks, that the concepts of NPNs, or non-public networks, or mobile private networks, I think though the ability to do that with either a shared core back into the national network or independent cores that are then virtually connected back into the main core, I think those NPNs offer a much simpler and easier solution to deliver those services, segmented from the national network, but still allow you to have that connectivity and not impact on the national network. So I think there's going to be a blended view there. I still believe in network slicing. I think it has some great things in terms of a national operator offering a specific service for, say, public safety or for transport connected vehicles, that type of thing, where you really want to prioritize traffic. But yeah, that would be my view at the moment.
Thanks, Peter. Any other questions? There was one part that Peter, you were mentioning about upskilling the enterprise customers. I totally agree with you that that a lot of enterprise, small medium enterprises, are still lacking of knowledge in terms of the real use cases and how they can actually incorporate those kind of use cases in their businesses day to day. And even in Malaysia itself, there's a lot of upskilling for the SMEs has been introduced, though the 5G has not been launched yet at this point of time, because in Malaysia, there's only 40% of the nationwide has been fiberized. So the government plans to actually make sure that the country is fully fiberized before the 5G has been launched. So at the moment, they want to focus on 4G. At the same time, a lot of initiatives have been taken by the government and also with the government-linked companies to upskill the enterprises customers to make sure they are fully aware about the tools, analytics tools and various different applications, so that they really understand that these use cases, the applications will be beneficial to improvise their productivity and the efficiency. So once the 5G comes, then at least the enterprise, they know that this will be very useful to them. So I believe in UK it will be the same scenario, right?
Yeah, I think in the UK we've had this wonderful opportunity of having government funding through the 5G testbed competition. So we've had numerous testbeds built across the country. We're still having more that are going to be built. There's another 6 winners due to be announced shortly. You'll get access to 15 million of 50% match funding from government to go build some more test beds. But one of the programs I've been involved in since this time last year, we have an umbrella organization called UK 5G. It's government funded, but with industry players in it. There's a large advisory board. But last year we set up some very specific working groups. So people like myself have joined into these working groups, and we're now engaging in certain areas. So there's an international one, there's a radio one, etc. The one I'm in is called SME and LEP. So SMEs, obviously we understand that. LEP is Local Enterprise Partnership. Now a Local Enterprise Partnership is a localized government organization, not with government employees as such, but with employees. And it's there to distribute centralized government funding locally. So this is all about growth funds, about doing things such as infrastructure. So they will put money in to help build roads, schools, other things, but they'll also put money into SMEs, to industry, business parks, enterprise zones, and so on. So what we have done over the last 9 months is to build a 5G program around educating those local enterprise partnerships, bringing them up to speed on 5G, the opportunity, how to get involved with central government, how to get involved with the test beds, and then also how this will then translate to the SMEs. So going forwards, hopefully what will happen is that the local enterprise partnerships will look at their own industrial strategy plans that they've had to put together. They will then look at how those SMEs fit into it. What we've had feedback is in which vertical sectors should we be focusing on. So since August, we've been running programs specifically looking at verticals. So we've done 2 or 3 on manufacturing. I've done one on rural. So up in Scotland, in the very north of the UK, big rural challenges there. They're putting funding in to build toolkits to allow people to actually engage and get that help, whether they be government bodies, local councils, SMEs, industry, enterprise, and so on. We're doing another one the end of this month, beginning of next month, on health. So that again will bring in different aspects into this. There's another group I'm working with called Tech London Advocates. We've set up a 5G working group. We're now focused in on how London, as being the largest startup and VC investment community in Europe, how we can actually bring 5G into that. So at the moment, London's got 5G coverage, but it's not there in the startup communities. It's not there within the local borough councils, with the mayor's office and the rest of it. So we're now running 2 or 3 parallel programs to actually do webinars, do engagement, do education, and so on, and bring those things together. So yeah, I think it's at that point in time now where everyone needs to get in and become involved.
Okay.
Yes, I can add Peter's comment as well. So in Scotland, the Scotland government also funding for the rural community spectrum sharing private network. That's part of the work led by Cisco at the moment. So we are working on that to provide the private network with a neutral host that we are actually having a communication with all the operators in UK in order to roll SLAs between operators to provide those neutral host private network.
Excellent. Any other questions?
There's one I'd put out to colleagues, because I was looking at the slides that were presented earlier and absolutely fascinated. I need to go back and take a look at the recording and re-look at some of those slides, because it does raise lots of other interesting questions. One of the things I'm sort of picking up now is that we are that far into 5G where things are beginning to get segmented and compartmentalized. So having a conversation now about 5G is not just one thing. You have to go quite broad. You have to bring in different levels of expertise and capability. So it's history, it's evolution. It's not easy for us as individuals now to be abreast of everything that's happening. It's a challenge, but I think it's what we're seeing is this maturity developing. The depth of the conversations, the depth of discussions, and I think the other thing I've seen recently, and hopefully some of the colleagues can sort of share on this, is the experiences that are coming back. The experiences that are coming back and actually rebasing. So within the standards, COVID I think has been useful because it's given the standards guys a bit more time to think about what they're doing. I mean, Release 16 will introduce so much more complexity. Release 17 will do the same again. So it's going to be a big challenge for operators to actually look at that and then deliver that out on a national basis. It's going to be an even bigger challenge for, say, a 5G private network that needs Release 17 capability and then Release 16 features, but then is reliant on Release 15. But to then say, how do I bring that together? How do I actually have this as a single capability, but then have it supportable? So one of the things I've been working with one of the 5G core software providers, and one of the challenges we're looking at is, do we have a single 5G core delivery? Yeah, do we deliver the same thing to all of the customers, or do we actually have specific tracks or paths, yeah, which actually follow new developments? Now that latter one is most probably great for the customer, but the expense and the cost of trying to do that is enormous. You know? So I think, yeah, we as an industry need to be very careful as to how we take this forward and how we deliver this and how we actually have this as a supportable, maintainable solution that we can all rely on. Those would be some of my thoughts.
The other area that I have a question in my mind also, how these big hyperscale players coming in like Google Cloud, AWS, Microsoft Azure, they also want some share in 5G, and very much they are focused into the edge. They have a completely product solutions for the edge offered directly towards to the industries like manufacturing, ports, airports, and all that, right? So these hyperscaler players also have a partnership with the mobile network operators as well. They are working hand to hand as well. Questions on board: do you think that this synergy will be some sort of a good team partnership, or it can be a competition between the telecom players and also the hyperscale players?
I think you need to have that partnership, honestly. I've always seen the telco community, and this is changing somewhat, but always seen them as having maybe really good capabilities when it comes to providing a network, providing the access for phones on networks. But beyond that, there's very little kind of traditional or inherent capabilities in those players. And so the more that they can expand and partner with industry participants, whether that be the hyperscale players or even more local cloud services providers, I think that can only help them. And then, really extending that into where, and I think, Peter, you were talking about this a little bit when it comes to vertical specific use cases, both of those types of players, the hyperscale cloud players, as well as the telcos, do tend to lack some industry focused view. And so it's interesting, the anecdote about AT&T, is actually surveying their account team to figure out who actually has, industry specific knowledge. I think that's absolutely critical as you begin to provide these services where customer requirements vary quite significantly from site to site, from industry to industry, from use case to use case. So I think partnerships there is really what's required to drive this market forward. And if somebody can take care of the cloud side of things, why not? It's almost like, why would a telco want to do that themselves when they can work with others? Obviously, it's a money thing, of course, but why not work with partners in that case?
I think one of the things that might come interesting, Harry, I'm not sure if you've seen this as well. One of the big buzzwords I've seen this summer in some of the 5G funding bids that I've been working with is data sovereignty. Yeah, in other words, if you're doing a 5G private network and it's in the manufacturing sector and it's for an automotive manufacturer, then data sovereignty is critical. Yeah? In other words, you do not want that data to go to a competitor. You do not want it to leak to somebody else. You don't want the press to get hold of this, etc., etc. So, and I think one of the things that will be an interesting discussion point is if you do have the Microsofts delivering a one size fits all cloud 5G capability, where's the data? Where's the data going? Who owns the data? Who has access to the data? So this is the same discussion that is ongoing with Google at the moment, with Amazon at the moment, with AWS and so on. And I just noticed from the European Union, yet another legal challenge into Amazon. So I think, data ownership, privacy laws, and the rest of it, from an individual are one thing, but when it comes to data that is part of an industry, then that's another thing. And especially if you then move to, say, the health sector, where there are huge issues with regards to who owns the data, who has access to the data, and so on. So one size fits all may not actually work in that area. You may really have to go down this custom route, and then 5G becomes on-prem, Now, data stays local. Now, anything that goes outside is managed, it's shrunk, it's curtailed. You know, it's the limited amount. Yeah, I just send some control plane stuff out, but everything else is kept here behind this nice big wall. And that's where I think, going back to what Harry was saying, the hyperscalers, there's the hyperscalers in the big cloud, but there's then the hyperscalers that not so much at the edge, but at the near edge. Yes. So in other words, I hyperscale this on my campus. You know, that way everything stays local. You know, I access it locally, I consume it locally, I store it locally. You know, I don't run the risk of it escaping somewhere else. But that would be an interesting discussion point.
Yes, I agree with Peter. And as I presented on the same slide on the first slide, that the advantages of the private network is the privacy and security. So of the data. Absolutely right, Peter was the most of the manufacturers, they don't want their data to travel around outside of the premises. But these IBM, Microsoft and Google and Facebook, they can play the game for the rural community, where they can actually deploy a core in a centralized or edge within their cloud, and save those rural community and save up some money for the operational cost for this community. So the private network, mainly that we need to look into the privacy and security of those industries' data. That's a very, very key point for this private network. Okay, Kanesh, is yours now.
Yeah, I mean, and if there's no any questions, then yeah, so the session has now come to an end, and I hope it was beneficial to everyone. I would like to express my sincere appreciation to all the speakers for your time and support. Thank you, Karim. Thank you, Jennifer. Thanks, Raul. Thank you, Harry. Thank you, Sriram, and thanks, Peter. Let's do keep in touch. We are all connected in the LinkedIn, and I really appreciate for your time and your support. Let's keep in touch, and till then, thank you so much to all of you.
Thank you. Bye-bye.
Thank you.